Hello students, welcome back to another tutorial video based on acids, bases and salts. These three terms, acids, bases and salts, are not just confined to your school's chemistry lab or textbook. Rather, they are present in our day-to-day life essentials, starting from our food, household commodities to medicines. So, let's learn this chapter in details. The topics that we will be covering from this chapter are chemical properties, dilute solution formation, pH scale, salts and their uses. At first, let us know what are acids and where from this term has been derived. To identify whether a substance is acidic or basic, we have two solutions. First, either to taste it. As we know, the taste of the food varies because each food item has its unique chemical composition, and based on their chemical nature, they are categorized into acids, bases, and salts. And second is to take the help of an indicator. For example, if we taste any citrus fruit, it appears to have a sour taste due to the presence of acid in it. So, from here we came to know acids are generally sour in taste due to the presence of acidic ingredients, and in fact these solutions are also acidic in nature. One common example is lemon water. If you add lemon juice in water, it too tastes sour. And this term acid has been derived from the Latin word acere, which usually means sour. Though we are defining a substance to be acidic by its sour nature based on their taste, but what makes this substance acidic? An acid is defined as a substance which contains hydrogen and which, when dissolved into water, gives hydrogen ions, and these hydrogen ions makes a substance acidic. Now, let's find out the types of acids around us. Based on their sources, acids are classified into two types: organic or natural, and mineral or artificial or inorganic. Organic means acids that are obtained from natural sources, like plants or animals, or better to say, that has a biological origin, are said to be as organic or natural acids. It contains carbon atoms, they are weak acids, it is insoluble in water, sometimes miscible with water. For example, citric, lactic acid, etc. Whereas mineral or artificial or inorganic, three terms for one acid. Mineral because these are prepared from the minerals of the earth. Artificial because they are prepared synthetically in laboratory and are also known as laboratory acids. And inorganic as most of the acids lack carbon atoms and do not have any biological origin. Apart from this, these mineral or inorganic acids are considered to be strong acids and they are soluble in water. For example, hydrochloric, sulfuric, nitric acids. This slide has mainly focused on the sources of acid, both of organic and inorganic. Organic acids are derived from both plants and animals, like you get tartaric acid from grapes, malic acid from apple, citric and oxalic acid from lemon and tomato, and lactic acid from milk and formic acid from ants. All these organic acids are weak in nature and are safe to have in our daily diet because it is vital for our health and well-being. Generally, all acids taste sour. Does this mean that all acids are safe to taste? Definitely not. Here comes the inorganic acid that are highly dangerous, and its sources are either minerals or prepared synthetically in laboratory. Till now, we have learnt about the types of acids based on their sources, but how to know which acid is strong and weak in nature? Acids can also be classified based on their strength. Those acids that dissociate completely to produce hydrogen ions, potent and corrosive in nature, bears the tendency to burn our skin or the surface on which it falls and has a pH value around 0 to 1, makes an acid strong in nature. Inorganic acids falls under this section, whereas the acids that dissociate partially to produce hydrogen ions, mild in nature, does not cause burn on your skin and has a pH value around 5 to 7, are defined as weak acids. And under this section falls the organic acids. Here comes some of the uses of acids. Hydrochloric acid is used to remove rust from metals. Sulfuric acid is used in automobile batteries, fertilizers, paints, plastic, and dyes. Nitric acid is used in fertilizers, plastics, photographic films, explosive, and dyes. And acetic acid, it is used as a food supplement, as a raw material, and used as solvent. We have already heard about the term rain, but what is acid rain and what are its causes, effects, and solutions? Let's have a detailed study on it, but before that, let us learn what are its causes. Humans cause many combustion processes that dramatically increase the concentration of acid-producing oxides in the atmosphere. Though carbon dioxide is present in a much higher concentration than nitrogen dioxide and sulfur dioxide. But the acidity of the rain is accounted by the presence of sulfuric acid in rainwater, which is formed when sulfur dioxide gas dissolves in falling rain. Though this sulfuric acid may be produced naturally in small quantities from biological decay and volcanic activity, but it is produced almost entirely by human activity, especially the combustion of sulfur-containing fossil fuels in power plants. When these fossil fuels are burned, the sulfur contained in them reacts with oxygen from the air to form sulfur dioxide. Similarly, the nitrogen dioxide gas and carbon dioxide gas dissolves in water to form nitric acid and carbonic acid and falls in the surface of earth in the form of acid rain, which is also known as acid deposition or acid precipitation. And its effects are: acid rain has been found to be very hard on trees. It weakens them by washing away the protective film on leaves, and it stunts growth. Acid rain also changes the composition of both soil and water bodies, making them uninhabitable for local animals and plants. It can additionally deteriorate limestone and marble building and monuments like gravestones. So, what are solutions? Well, the solutions are to optimize fossil energy processes, transition to renewable energies, confining the use of fertilizers and pesticides, restoring environments, saving energy, reducing consumption levels, education, and obviously government regulations. Now let's understand what are bases. Bases are bitter to taste. For example, coffee. If you taste it, you feel bitter because of the presence of quinine in it. Similarly, the substances that are bitter to taste have basic ingredients, which means presence of oxygen along with hydrogen, which is called the hydroxide group, which is released into the aqueous solution. And the solution of the bases are also basic in nature. Here comes some of the uses of bases. Sodium hydroxide. It is used for manufacturing medicines, rayon, paper, textiles, soaps, and detergents. Potassium hydroxide, it is used for the production of disinfectant. The function of disinfectant is to remove the germs, like we use Dettol. Then, in the preparation of biodiesel, manufacturing drain cleaners, liquid soaps, lotions, and shampoos. Magnesium hydroxide. It is used for the preparation of antacids to neutralize the acid in our stomach. Calcium hydroxide. It is used for manufacturing bleaching powder, cement, and agricultural pesticides. It is used in whitewashing and wastewater treatment. Whereas ammonium hydroxide is used for manufacturing nylon and plastics, and it is also used for removal of stain. Based on how they take part in reaction, bases are of two types: strong bases and weak bases. Strong bases, they are corrosive in nature. They can burn our skin. Example, sodium hydroxide, potassium hydroxide, etc. Whereas weak bases are not corrosive in nature and even do not cause burn on skin. For example, magnesium hydroxide, sodium hydrogen carbonate, and so on. These are some of the general properties of acids and bases. Acids, as you have learned, that they are sour in taste. Similarly, bases are bitter in taste. Acids, they are soluble in water, but few bases that are water soluble are termed as alkali. Acids, they are corrosive in nature, and bases that are strong, they are also corrosive in nature. Acids are stored in plastic or glass container but not in metal container because metals can react with acids, and bases, they are slippery to touch. But one common similarity between acids and bases is that both can conduct electricity. Next comes neutral substances. Neutral means the substances that are neither acidic nor basic, and some common examples are pure water, glucose, and common salt that we usually have in our home. Now, let's know what is salt and what is the basic similarity between salt formation and neutralization reaction. A salt is formed when an acid and a base react. The reaction in which acids react with bases resulting in the formation of salt and water are called neutralization reactions. So, the basic similarity between them is the formation of salt. Whereas, one more important property of neutralization is that when an acid is mixed with a base, they neutralize or cancel the effect of each other, which we will learn in details in the next slide. A salt can be acidic, basic, or neutral. In acidic type, strong acid reacts with weak base. Here, the strong acid is hydrochloric acid, and let's consider a weak base such as ammonium hydroxide. And when they react, the salt formed is ammonium chloride, which we can say as acidic salt. Similarly, in basic type, weak acid is react with strong base. For example, weak acid, for example, carbonic acid, and strong base, that is sodium hydroxide. When they react with each other, it forms sodium carbonate, which is a basic salt. And in neutral, both strong acid and strong base react with each other. That is hydrochloric acid, as you know, it is a mineral acid and it is strong in nature. And sodium hydroxide is a strong base. When both of them react with each other, it forms sodium chloride, which is also known as the common salt. These are some of the uses of salts. Sodium chloride, whose common name is common salt, it is used for seasoning and preserving food, essential in life processes. Sodium carbonate its common name is washing soda. It is used in detergent. Sodium bicarbonate. Its common name is baking soda. It is used in baking powder, manufacturing glass, and fire extinguisher. Calcium carbonate. Its common name is limestone and it's used in construction of building and purification of iron. In neutralization reaction, the acid loses its acidity and the base its alkalinity. As a result, a neutral solution is obtained. In this slide, you can see some of the images of neutralization reaction that we observe in our everyday life. So, let's study in details about their remedies. In indigestion, hydrochloric acid is secreted in our stomach that helps in the digestion of food. And its excess secretion could lead to acidity and indigestion. To neutralize its effect, one common antacid known as milk of magnesia that contains a base known as magnesium hydroxide is given in order to stop indigestion. In case of soil treatment, if the soil is too acidic, it is treated with either slaked lime or quicklime, which is a base. And if the soil is too basic, it is treated with organic matter such as fertilizers that are obtained from vegetables or fruits as they are acidic in nature. In curing tooth decay, one of the best common application of neutralization of acids is the toothpaste. Toothpastes contain an alkali that neutralizes the weak acid, that is lactic acid, which is produced by the bacteria and prevent tooth damages. In sewage treatment, several industries produce acids as waste. If they are allowed to flow into water bodies, these wastages would affect aquatic organisms. Slaked lime, that is calcium hydroxide, is often used to neutralize this acidic waste let out from the factories. Do you know how can we reduce the sharp pain caused by ant sting? Well, some peoples are highly allergic to ant sting as it releases formic acid and it is neutralized by rubbing moist baking soda, that is sodium bicarbonate or calamine solution, which contains zinc carbonate on the affected area. We do not prefer to test for determining any substance in terms of knowing its nature, as it may prove to be very dangerous, which may even lead to fatality or death. So, the most safest solution is to take the help of an indicator. Now, what is indicator? Indicators are a mixture of dyes or compounds that assist in determining whether a substance is acidic or basic with the help of color change. And they're basically of two types, natural and synthetic. First comes litmus. It is a natural indicator that is extracted from lichen. It retains its color, that is purple, when it is neutral, that is neither acidic nor basic. It comes in two strips, blue and red. The blue litmus paper turns to red color when it is dipped in acidic solution, and the red litmus strip, it turns into blue when dipped in basic solution. China rose is a light pink colored solution which is extracted from the red flowers of China rose plant. It turns its color into magenta or deep pink when dipped in acidic solution and turns green in basic solution. Turmeric is another natural indicator which retains its color yellow in acidic solution and becomes red in basic solution. One common incident that happens in our everyday life is dropping of foodstuffs in our dresses, which leaves behind yellow stains in our dress. And in order to remove it, soap, which is basic in nature, is scrubbed on it. And it turns the color of the turmeric in the curry into red. Phenolphthalein and methyl orange, these two are synthetic indicators. Phenolphthalein is colorless in acidic and turns to pink in basic solution, whereas methyl orange, it retains its color red in acidic and turns yellow in basic solution. While learning about acids and bases, you have learnt about the term pH. But what is pH? pH scale is a numerical representation of the acidity or basicity of substances. It varies from 1 to 14. Solutions with a pH value of less than 7 are referred to as acids. pH value more than 7 are considered to be bases, and pH value of 7 are referred to as neutral. Here, some of the examples along with pH range is shown. Hydrochloric acid is a strong acid and its pH lies around 1 and hence it cannot be ingested. But pH of orange and tomato juice lies between 4 to 5 and hence is safe to ingest. Pure water is neutral as its pH is 7, whereas milk of magnesia is a base and its pH is around 9 and hence it can be taken easily by the human body. So here the chapter ends. Hope this tutorial video helped you in dealing with the concept of acids, bases and salt and their action and reaction. Thank you.